Okay, Alex, are you ready?
I'm okay. Could you hear me?
Yes, yes. Okay,
perfect.
The speaker is Alexandre Pitti from the University of Cergy-Pontoise in Paris, France, and he will give a talk titled "Artificial Skin to Recognize Object Materials and Constructing the Robot's Body Image." Alex.
Thank you, Matej. So yes, I would like to speak about artificial skin. We speak about it the days before. We want to present a new technique based on electrical impedance tomography, but based on multi-frequency. And the thing is how we can exploit the similarity with the tactile information. We know that the touch sense is frequency dependent. We have a mechanoreceptor for texture detection, light touch, heavy pressure and stretch. And we wanted to have this technique of tomography with multi-frequency to have this kind of feature also. This is based on our new model and a new paper from Sensors last year. And 5 years ago, we have a model of electrical impedance tomography in which we learn with unsupervised learning the topography and the mechanoreceptors of completely unsupervised manner, the medium or the electrical field inside this medium, which is a piezoelectric sheet of polymers. So we have shown that by learning, we can be really fast. We have a really slow, small precision error and a fast reconstruction, 40 Hz, which is 10 times faster, but model-based, which is something interesting. And we show also that we can do some shape and location detection. We can be really sensitive to the weights of objects within the skin, and also to the displacement with 2 millimeter detection. So this is what we have before. And also it's possible to detect the shape of object roughly. It's not that perfect now, but using the new technique of multispectral tomography, we can now detect the temperature and also the material tap in contact with. So the standard model is like that. You get here the tension and the current injection. And now you have a 3D volume. In fact, you use the frequency for each measure that you take in the tension matrix. So you have much more data. And using these data, you can detect now object, something before it was not possible to detect only the material, only metal, but now it's possible to detect the impedance of a hand, plastic, apple, whatever, and we can really discriminate this information. So for soft robotics or robotics that to feel our own body or to feel someone that's touching or an obstacle, this is really good. We can have a covariance matrix showing that we can perfectly discriminate everything, and also the temperature. If you add the motor information plus tactile information, then you can control quite easily a robot. If you don't know what is the left, right, up, down, well, combining the two information, you can do compliance control, which is really something difficult to do with mathematical model. So using really the skin, you can go in that direction. And if now you use motor information, touch information, plus vision inside a really simple neural network, not a deep network, you can really to do some self-supervised learning and to learn the kind of body image, body schema, and to have a sense of distance between your own body and the external. So we don't use any tags to know where it is on the visual information. The tactile information is used as a guide to correlate the posture and the visual information. This is highly similar to what we have in the parietal lobe when we have these neurons sensitive to the distance to the skin information, doing some visual, motor, and tactile information. And now in the last experiment, we have also, if you have the postural information, visual information, motor information, and you add the new information linked to something else, the tools of over, then you can also embody new things inside your own body, like a tool. And you can even do some control of a tool without error. So somehow, having really from the core information of the skin, you can go to a high level cognition somehow to incorporate tools, but also why not others for doing the imitation. This is what we have also in the parietal cortex. And this is the work by Eric, really famous on the embodiment of tool use. I thank you. I have much more things to say, but the future works are on prosthetics and social robotics. And we are really open to collaboration with our lab on soft robotics and neuro robotics. It was really a fantastic session these days, and I want to continue on that with you. Thank you very much.